All right, so today we're going to be going over Cow programming language. All right, so Cow is part of the esoteric family of programming languages. And now these languages are known for not having any mainstream use among regular software engineers. An esoteric programming language, sometimes shortened ESOLang, is a programming language designed to test the boundaries of computer programming language design. For instance, as a proof of concept, as software art, as a hijacking interface to another language, or more, more commonly as a joke. All right, so now we're going to talk about the types in Cow. So basically within Cow, there's not really that many types, so to speak. There's not really any data structures either. It's really just pointers and incrementers, and that's pretty much it. There's no real predefined types within a programming language. If I was to guess what kind of type it would be, I would say it's likely not functional. And I don't really think it's going to be functional. This is just because with my experience with the language, I don't think that there's really any, functions really aren't treated that much as an object within the computation of the language. I would say it's probably definitely more so towards either logic or it's either logic or object oriented, but I'm not 100% sure. But anyway, so basically there are really only memory blocks that can store integers. Memory blocks can be incremented by one or decremented by one, and memory blocks can be changed or copied. Also move likely as few safeguards for programming, but then again, there's not really that much going on here, so I wouldn't really worry too much about security either. All right, so now we're going to go over, I just want to look at this more in a broader context. So I kind of wrote, I made a little Python code just, so we can get a better idea of how this, about how like this would work. So basically, I would imagine the Cow language as basically two different things as, so we're gonna basically, it can be defined within two different contexts. The X is just going to be what's going to be, for instance, our memory space. C is going to be our actual incrementer, going through all of the commands. Current position is going to be where our current position currently is, or where we're currently pointing to. And C is going to actually be what we're going to be using the C is going to be what we're going to be using, incrementing through all of the different commands. All right. So now we're going to go over all the different everything within this language. So we're going to start with moon number one. And at moon number one, we can basically see it basically just decrements C until you reach MOO. It can function a lot as a loop. Essentially what happens with lowercase mu and then uppercase mu over here is that basically it goes through, it basically repeats whatever is between those two commands over and over again until the incrementer value or whatever value is it started the loop on, which would be, like for instance, the memory block 0, it would until that's 0. So every iteration you're going to have to decrement it by 1. All right, so now we're going to move on to moon number 2, and now this is basically just moving the current position back 1. So if you were at memory block 1 in the in X, now you're at memory block 0 after executing this command. And then we got moon number 3, which is basically just the opposite of moon number 2, and it just moves your current position forward 1 block. All right, and then we got moon number 4, and now moon number 4 is a little bit hard to understand how it was going to be executed, but I don't honestly, when I was developing all the programs, I didn't really use moon number 4 that much. Basically, it executes the current value in the memory block as if it were an instruction. The command executed is based on the instruction code value. For example, if the current memory block contains 2, then the move command is executed. An invalid command exits the running program value. 3 is invalid as it will cause an infinite loop. I wasn't too sure about that one, but I didn't really end up using it. All right, so now we're going to go move to mu number 5. Now, mu number 5 is basically what we would consider. So in some ways, this is kind of like a print value. It's not 100% like it. Basically, what mu number 5 does is that it either prints the value, which is if the current the value in the memory block is 0, then it just takes something from the input. But if it's not 0, then we print it out, but we just convert the integer to ASCII. All right, and now we're going to move on to mu number 6. Now, mu number 6 is going to be the decrementer of the value, which is going to be very different than the decrementer of the current position. Now, unlike the other ones, the current position, this is going to decrement the current, the value that is stored within the memory location. And now, obviously, just like before, mu number 7 is just going to be the opposite of mu number 6. All right, now we're going to move on to mu number 8. And now mu number 8 just works in tandem with mu. And basically, that's what happens. You can forget about the decrement curve. Now, and then OOO basically just resets the current memory value to 0. It's in some ways very similar to realloc in C. Basically, whatever is in that current memory value, it just sets it back to 0. I don't really think that there's too much for worry about here in terms of memory. But I would definitely say that if you're running in some ways like Fibonacci numbers and stuff like that, I would say triple O is definitely in some ways important. It's very much like the garbage disposal in some way. All right, now MMM, this is also another one I was really unsure of how to use, but basically how it works is that it essentially kind of just copies a value into a register. And then that register, and then you can just move it on to whatever value. For instance, if you just had MMM, you had MMM, and then you can just say where you want that value to move to, and then put another MMM. That's basically how you would copy and paste. All right. And now, and then we're going to move on to OOM, which is basically the same as the mu command that we talked about over here with if the current position equals 0, but instead it basically just prints the integer no matter what. It does not convert it to ASCII. All right, and then we're going to move on to OOM, which is the lowercase. This is basically going to be very similar to the mu over here in terms that it basically takes an input, but the difference here is that it only takes an input. It never prints a value, so to speak. And also it only takes an integer from standard in, unlike the other kinds of memory. All right, so now here's some programming examples. This is Hello World, but this is using absolutely 0 loops. And it's really important within the mu programming language that we actually use loops, because it really, really, really cuts down a lot on the computation. And now this, as you can see here, the difference between this Hello World and this Hello World is massively different, because over here we use loops, which is if you look over here you can actually see where the loop begins. It's MOO with all 3 caps, and that's where the loop begins. And then we can also see that it repeats all the way down until the MOO over here. And now all the values up here basically are just incrementing the initial value of the loop. All right. Now this is also very interesting. Printing integers is actually a lot quicker within mu than printing letters. And this is largely because the only real way that you can print values in the programming language that aren't integers is basically just incrementing all the way to that value, either through loops or not through loops, and that takes a while. So that just takes up a lot of computation. All right, so now we're going to move on to some examples here. I think basically how this works is that I'm going to move against the power box here. Basically, so we're going to go over some examples that I think are really important. So first off, we're just going to start off Let's see. So we're just going to do, this is just to show really what the programming is like, just to begin with. And basically, and then you're going to have to compile the C code. This is pretty much just how we compile here. Then just presentation.cow. Now we can see here basically what that command does is that it just the memory looks like this. So we got a 1 stored over here in this value. The 1 always points directly. You always see that it points directly towards the memory block to begin with. There's no real boilerplate here. You can kind of just jump in. And then we'll move on here. So for instance, we're just gonna model a loop here just so we get an idea of how loops work, because loops work here a little bit, they're a little bit strange just to begin with. So this is so as you can see here, this is really what we can also. I'm just gonna type this out real quick. So basically what we're going to do here is that we're basically going to go, first we're going to increment 2, and then we're going to start the loop over here. And basically what happens here is that we're going to move the memory block forward, and then we're going to increment that 2, and then we're going to move the memory block back, and then we are going to decrement that current value, or which is decrementing the ones up here. And that's really how you that's how you do loops. So we're going to see here. So the second one should be 2, and then the first one should be 0. So if this works right, okay, yeah, actually, I did that actually, yeah. So it's going to be 4, and that's just because we had 2 commands up here and then 2 commands down here, and as you can see, everything within these brackets right here executes as these many times. So for instance, if we just did MOO over here, and then we did another MOO over here, this will actually return us a 9 now. And now this is really how it's important. Now this is really why it's important to have loops in the program. Yeah, so that's my little demonstration. Anyway.